Yeah, like sticks is what I normally say.
Ah, sticks. Yeah, yeah. Which material are these sticks, nanosticks, made out of? And why do you make sticks? Why don't you make cylinders for it? You mainly work on these. Can we call them pillars or
Um,
needles, or what can we call them?
Nanofibers is what we normally call them. Or
Okay.
like, yeah.
In real life, like in common people language, what can we call it? Can we call it like hair? Nano
Uh,
hair? No.
yeah, like sticks is what I normally say.
Ah, sticks. Yeah, yeah. And why do you make them? First, two questions. Which material are these sticks, nanosticks, made out of? And why do you make sticks? Why don't you make cylinders, for example? Tell me.
Yeah, that's a good question. So we work with polymers. So we work with what we call block copolymers. So polymers are like long chains of big molecules that are made up of lots of repeat units of the same thing. Or and if you have one polymer chain that has two different what we call blocks, so two different types of molecule that make it up, you can get it to go through a process which is known as self-assembly, which is a bottom-up way of producing nanomaterials. There's two ways of making them. There's like the top-down approach, which is to use something like lithography or to like engineer things really smaller and smaller and smaller. And then there's the chemistry way, which is to build molecules bigger and bigger and bigger. And so self-assembly is this process where molecules will organize themselves into the lowest energy state, and you can control like the properties of that. And there's one interesting thing about people that work in nanomaterials and different like shapes is that everybody uses an analogy with something from the real world. So, for example, like fibers, hairs, sticks, cylinders. And sometimes there are people use different words, and sometimes there are like subtle differences between them. So the difference between a cylinder and a stick, in my mind, would be the cross section. So the cross section of a cylinder would be round, and then the cross section of like a fiber or a nanofiber would be like rectangular or and that would be down to the chemistry of the polymers you're working with and how they like to assemble. That would
Ah,
dictate that.
ah, okay. Okay. So what you mentioned, top down, that is something that happens, for example, in semiconductor industry with lithography and all of that.
Hmm.
But in real life, if you want to take an example, is if you want to build a building, so top down would mean that you start from the top floor, or not even, you start from like the roof and above that, and then you make it like smaller and smaller, and then you cut it from different sides. So that's like the top down, and bottom up is the foundations, and then first floor, like ground floor, first floor, second floor. That's so what you do is more of the bottom up, which is the
Hmm.
ground floor, first floor, second floor, right?
Yeah, yeah, yeah. So it's kind of like if you're gonna sculpt something, think about is like a top-down approach would be taking like a block of stone and then chiseling it away until it had the shape of whatever you wanted. Whereas bottom up, which is what we do, would be to just take lumps of clay or something and then mold it and create it into the shape you want rather than removing it.